Thanks for watching Readers Tutorial Academy Online. Please, I want to implore you, if you have not subscribed to this YouTube channel, please do well now. Press on the subscription button and press the notification button in order to see all the complete tutorials video on this semester courses. And today we'll be considering university elementary mathematics. Specifically, the topic we are talking about today is trigonometry. And I want you to watch this video to the end. Don't stop watching. Make sure you watch to the end so that you can gain a lot of things. Thanks for watching once again. Now, what do we mean by trigonometry? Trigonometry is derived from the Greek word, the synthesis of two Greek words known as trigono and metra. Trigono means triangle and metra means measure. So in other words, you can divide trigonometry as a branch of mathematics or a mathematical term that is concerned about the solution of triangle, concerned about getting the side and the angles of the triangle, because a triangle is a three-sided polygon that has three angles and three sides. Now, that's all about derivation of trigonometry. But we're not going to that. What we're doing is to go into the real work, which is the calculation aspect, which you are expected to know very, very well. So now, this topic will be divided into two aspects. First thing, you have to know the trigonometry ratio. What are the trigonometry ratios? These are the things we are familiar with, but they are the basic building block for you to be able to understand the concept of trigonometry. And the first thing I'm going to be talking about here is the trigonometry ratio, the trigonometry ratios. The trigonometry ratios, popularly known as what? Popularly known as SOCA. So now, how do we come about these trigonometry ratios? Now, from the right angle triangle, when a right angle triangle is a triangle which has an angle of 90 degrees. A right angle triangle is a triangle that has an angle of 90 degrees. It is not a right angle triangle because it is facing left or right. No, it's a right angle triangle because it has an angle of 90 degrees. An angle of 90 degrees is an angle of a right angle. An angle 90 degrees is known as a right angle. That is an angle that has a magnitude of 90 degrees. Now, let me do a right angle triangle for you. A right angle is the diagram for a right angle triangle. You have a right angle triangle here. The right angle triangle. You have a right angle triangle. Now, this is a right angle triangle, and we are going to label this triangle triangle, a right angle triangle. Now let's label it. Now, this is our what? A, these are B, and these are C. When we are labeling the right angle a triangle, when we are labeling a triangle, the calculator is used for the angles. The calculator is used for the angles, while the small letter is used for the side. The side. There will be that whenever I write calculator, this means an angle B, this means an angle B, this means an angle what? C. The side facing the what? The angle B, the side that's facing this angle B that is opposite what? The side that is directly opposite to angle B is what we call side. The side that is directly opposite to angle C, that is what we call side C. The side that's directly opposite to what? Angle A, that is what? Side A. Now, from here, this is how to label any given triangle, whether it is what? Whether it's right angle, isosceles triangle, equilateral triangle, or scaling triangle. Now, since we have labeled this in terms of size and angle, now there's a specific labeling that is pertaining to a right angle triangle as well. Now, a right angle triangle has three sides. The three sides are given names. These sides are given name just as we have labeled it as letter. So these sides are also given name. The longest side is known as what? Hypotenuse. The longest side is known as hypotenuse. The longest side is known as hypotenuse, abbreviated as HYP. Now, the side that is facing an angle, like considering this angle C now as theta, the side that is directly opposite to this word, angle C, which is theta, is what we call opposite. Opposite, abbreviated as OPC. Now, when the sides that have what? The right angle standing with the angle side by side is what we call adjacent. Abbreviated as what? ADJ. Now, from here, we have successfully made what? The side of what? Of the right angle. Now, from here we can proceed to derive our trigonometric ratio. Now, the first thing we need to know that is what is the first trigonometric ratio, which is sine of angle. Sine of angle what? It's a sine of angle theta. Sine of angle theta, also known as what? It is given an acronym of so. So it is given as what? Sine theta is equal to what? Sine theta is equal to what? From the so opposite all over what? Adjacent. Opposite over adjacent. And what we have now from our diagram, our opposite is what? C. And our sorry for that. Sine theta is equal to opposite over what? Hypotenuse. And our opposite is what? Our opposite is C. Our hypotenuse is what? B. Now let's move to the next one, which is what? The cosine. We have what? The cosine of what? Of theta. The cosine of theta, which is known as what? Now the cosine of theta is known as that. So it is what I mean as what? Cos theta is equal to what? Adjacent all over what? Hypotenuse. That's what we call car. So what's our adjacent? Our adjacent is A all over what? All over hypotenuse, which is what? Adjacent over hypotenuse, which is what? B over what? B also adjacent over hypotenuse A over B. And the last one here is what? Tangent of angle theta is known as what? So tangent is popularly known as tan. Theta is equal to what? Opposite over what? Adjacent, which is equal to what? It is equal to opposite over adjacent, opposite over adjacent, opposite over what? Adjacent. C all over what? A. C over A. Now, tan can also be divided. It can also be divided in another way. Tan can also be divided in another way. How can we divide tan? Tan theta is the ratio of sin theta all over what? Cos theta. Look at this, you can see sin theta. Tan theta is also given as sin theta. Tan theta is also given as sin theta all over what? Cos theta. What do I mean? What do I mean by that? If you look at this very well, if you divide, what's your sin theta? Because sin theta is C over here. Is C all over what? B. Your sin theta from here is what? C all over B. And your tan and your cos theta is A over B. So it means that sin theta here, which is C over B, divided by your cos theta, which is A over B. That is your divide. Just let us have it as A. Just use the division sign here. A over what? B. Now when you proceed with what? When you change the division sign to multiplication, then the multiplication trig inverse will take place as this. We have what times, and the denominator will go what, which is b all over what a. This one cancel out. You can see that what we're having left here is what c over a. You can see that it is the same thing as tan theta equal to opposite over what adjacent, which is c all over what a. So tan theta tan theta, one of the formula of tan theta is what is 12. Another one is what tan theta is equal to sin theta all over what cos theta. This is very important because as time goes on, we will be using this one as well. So this is basically on what? On trigonometry what? Ratio. Now let's move to what? To the reciprocal what? Ratio. The reciprocal what? Ratios. The reciprocal ratios. What do you mean by reciprocal ratios? This is when the trigonometry ratio is what is being reciprocated. Now, for example, now when we reciprocate what this sign of angle, what we have, the first reciprocal ratio that we have here is cosecant of an angle, cosecant of an angle what? Of an angle theta, cosecant of an angle theta. The cosecant of an angle theta is popularly known as cosec theta. Please get used to it. Cosec theta, and cosec theta is 1 over sin theta, which is equal to 1 over sin theta. Please, when you look at it, 1 over sin theta, what is over sin theta? That is c over b. Now it means that you are going to have 1 all over c over b, 1 all over c over b. And when you do the mathematical expression, you are going to be 1 divided by c over b, which is equal to what? 1 times b all over what? C, because I've changed it. So we have an answer to what? B all over what? C. And that's that about that. But this is not what? This is not what. So we have b over c. Please know that cos theta, which is 1 over sin theta, is in as b all over what? C. I'm just trying to express this. It's not necessarily what you must go into this in detail. But these things are being obtained mathematically. But as time goes on, we don't need to pass through this for you. I want to let you know that these are how these things are being gotten. By the time we are going forward, we'll be skipping some steps. So stay with me. So number 2, we have what? We have the second reciprocal that we have. The second reciprocal ratio that we have is secant of an angle theta, secant of angle theta, popularly known as what? Sec theta. Sec theta is equal to 1 over cos what? Theta, which is equal to 1 over cos theta. So I don't need to go through this process. It's just 1 all over what? A over b. So now become b all over what? A. B all over A. I hope that is what's clear. So now the third one is what? Is the reciprocal what? Ratio of what? Tangent, which is what? Cotangent of the angle, cotangent of angle theta, popularly known as what? Cot theta, which is 1 all over tan what? Theta. Now this one comes in 2 forms. It comes in 2 forms. So we know that what? Cot theta is given as what? 1 all over what? Tan what? Theta. And we know that 1 over tan theta is c over what? We know that tan theta is c over a. So when you find this local of what? Of tan theta is what? A all over c. So that's the first one. Also, you know that cot theta is 1 over tan theta. 1 over tan theta. And we also say that tan theta is equal to sin theta all over what? Cos theta. So in other words, when you find the reciprocal of this formula, we know that what? The cos theta will go up and the sin theta will come down. So we have cos theta all over what? Sin theta. This is another way of writing cot theta. Cot theta is equal as what? Cot theta is equal as 1 over tan theta is equal to what? Cos theta all over sin theta. This is very, very important. we have obtained our trigonometry ratio and we have also obtained our reciprocal ratio. Now let's move on to get our trigonometry identity. Trigonometric identity. Trigonometric identities. This is very, very important. These trigonometric identities will serve a lot of purpose, even when you are doing what differential calculus and what integral calculus. These trigonometric identities is going to be you are going to be recording for it often and often when you get to some area in what differential calculus, when you are asked to do the differential calculus of a trig functions and so on and so forth. And if you have this knowledge of trigonometric identities, might be able to be challenging. Please and please, I want you to really follow me on this aspect as far as this one is concerned. Now, trigonometric identity, how do we come about that? Now let's consider the triangle once more. So we have a right angle triangle A, B, C. Now we have side A, side B, and side C. We have side A, side B, and side C. Then don't forget that these are hypotenuse. These are adjacent, and these are opposite. I consider this theta as this side that is facing the angles are opposite. The longest side is hypotenuse, and the side which carry both the right angle and the theta we are considering side by side, so we call adjacent. Now from here, in order to get our trigonometry identity, we have to apply another rule that is very, very applicable to trigonometry ratios, which is Pythagoras theorem. Whenever we are finding on the side of a right hand triangle, we can use this rule called Pythagoras theorem. Using Pythagoras rule, which is hypotenuse square equal to opposite square plus adjacent square. So what do we have here? We have our opposite, our hypotenuse is b square plus plus opposite square, which is b square is our hypotenuse equal to our opposite is c square plus adjacent is a square. We check, look at this very well, we can say we have b square equal to c square plus a square. Let's decide to divide through by by b square. So divide equation divide equation 1. Then name this one equation. Divide equation 1. I'll divide 1 by divide 1 through a, or divide 1 through b square. Okay, I come again, divide 1 through, this, you can divide this one, equation 1, then divide 2 by b square, divide 2 by the b square. So we have b square all over b square equal to c square all over b square plus a square all over b square. So we have b square cancelled, we have 1 equal to it. So this one cancelled, we have only 1 left. So we have c all over b all square plus a all over b all square. Now we have c over b all square, a over b all square. So since we have c square over b square, we can decide to put it in the same bracket and square it. So that's what happens here. Now from here we can now go back to our derivation in trigonometric ratios. So we say sin theta is equal to c over b, meaning that whenever we see c over b, we can put sin theta. So since sin theta is equal to c over b, and cos theta is equal to a over b, then we have 1 equal to what? Sine theta bracket close square plus what? Cos theta bracket close square. So when what? When you open down the bracket, you use this to multiply this. We are going to have 1 equal to sine square theta, not sine theta square, not sine square theta plus cos square theta, not cos theta square. So this is this trig form, this trig that we are having here is what we call, this trig we are having here is what we call first trigonometry identity, which is also known as what? Fundamental what? Identity. It is the identity in which all other identities are built on. It's just like a foundation. So trig identity says sine square theta plus cos square theta is equal to what? 1. Or you can say 1 is equal to sine square theta plus cos square theta equal to what? Or equal to what? Equal to sine 1 is equal to sine square theta plus cos square theta. So whichever the place you wanted to what? Put it. So now let's move on from this place and let's what? Continue from there. So from that place you can now decide to divide the first identity, divide the first trig identity, the first trig identity now. Divide the first trig identity by the first trig identity by true. Divide the what? The first trig identity true by what? True by sine square theta. So I'm going to divide this first trig identity true by what? Sine square theta. So we have 1 equal to sine square theta plus cos square theta. So we have what? When you divide it with what? 1 sine square theta equal to sine square theta all over sine square theta plus cos square theta all over sine square theta. Now, what will this one give us? What will this one give us? This, remember, follow. So this one sine square theta, 1 sine square theta here. We have made some point that whenever we have 1 over sine theta, we have cosec theta. So in other words, this 1 over sine square theta will become cosec square theta equal to now sine square theta all over sine square theta. This one will cancel out, and this one will give us 1 plus what? Cos square theta over what? Sine square theta. Cos square theta over sine theta is related to one of the what we have here. We said cos theta over sine theta here will give us what? Cos theta over sine theta will give us what? Cot theta. So this one eventually will give us what? Plus. Because it is square now, it's now because cot square what? Theta. So this is the second what? You can call this one second trig identity. It can be second, you can call it second, but not necessarily second, it can be third, depending on what you use to divide through. So second trig identity. Now the third trig identity, because I don't want to waste more time here, the third trig identity is obtained by now. Now let's do that. Now let's divide through by what? Divide first trig identity, which is the one given there, the first trig identity true by cos square theta this time around. So what do we have? 1 all over what? Now let's write the first trig. First trig say 1 all over 1 is equal to what? Sine square theta plus what? Cos square theta. So 1 all over sine square theta equal to what? Sorry, this time around I dividing by what? Cos square theta. So it will be what? 1 all over cos square theta equal to sine square theta all over cos square theta plus cos square theta all over cos square theta. So we are dividing through by cos square theta. So what do we have now? 1 over cos square theta here will give us 1 over cos theta is what? Second. But this time around we are having square here. So 1 over cos square theta will be what? Sec square theta, sec square theta, equal to sin theta over cos theta will give you tan, which is what? Sin theta over cos theta will give you tan. So sin theta over cos theta is tan. So it means we are going to have what? Here we are going to have tan square theta plus this one cancel out, we have plus 1. So this is your trig, the third what? This is the third. Come back, here are some examples on what trigonometry that we are discussing. Here is an example on what trigonometry that we are discussing. So prove the following expression. Prove the following trigonometric expression. Show that this trigonometric expression are correct. That the right hand side is equivalent to the what? Left hand side. It's equal to left hand side. Although we are going to be doing CBT exams, likely your own exam might be what theoretical. But if the CBT expect something like this, if it's theoretical, expect something like this, because they know the way they can set it. All you ought to do is to prepare yourself. You must be able to know at least the three what trigonometric identities often, but you're able to record them often. The first trigonometric identity we have to 1 is equal to what? Sin square theta plus what? Cos square theta. 1 about sin square theta plus cos square theta. Mind you, they can treat this formula here. They can express it in any form. They can, some people may write it as sin square theta plus what? Cos square theta equal to 1. Or you might even decided to write it as what? As sin theta is equal to 1 minus cos square theta, then the square root of this. So it is still the same expression. These are the things they can do in your CBT. So just know that they are still referring to first trig identity, whichever the case might be. So what they just do is that they have transferred this one to the other side, and they have taken the square root of what? Both sides. That's why we are having sin theta is equal to root of 1 minus what? Cos square theta. It's still the same thing as first trig identity, first what? Trig identity. So now the second one that we're having is what? Second one that we're having for second trig identity that we use as second trig identity here is cosec square theta equal to what? 1 plus what? Cos square theta. Why the third one is what? Sec square theta is equal to tan square theta plus 1. These are the three trigonometric identities that you need to be able to recall often. Now, let's delve into the question. The first question here is what? Is equal to square root of 1 plus cos square theta all over what? Square root of cos square theta over 1 plus what? Tan square theta is equal to what? Say you prove is equal to tan theta. You prove that the thing inside square root is equal to what? Cos theta. How do you prove that this is cos theta? Now, mind you, you have to start your work. When you have to start your working from the left hand side to the right hand side, you have nothing to do with the right hand side. The right hand side is the answer. You don't need to tamper with the right hand side. What you also need to work with is the left hand side. So now, if you are able to get the right hand side as a solution from the left hand side, that means you have arrived at the end point of the problem. Now, let's do this now. How do you solve this question now from the left hand side? This is the left hand side. This is what? The right hand side. So we have what? 1 plus cos square theta all over 1 plus tan square theta. So now look at this form of trigonometric identity. The same with this 1 plus cos square theta. Now look at this. It is very straightforward. 1 plus cos square theta is equal to cosec square theta. Cosec square theta is equal to 1 plus what? Cos square theta. So in other words, we are going to have what? This square root can be changed to this expression can be changed into cosec square theta all over. Now, this one, in fact, this one is also what? Tan square theta plus 1. It's the same thing as what? 1 plus what? Tan square theta. whichever the case, it's still the same thing. So sec square theta is the same thing as what? Tan square theta plus 1 plus 1, tan square theta plus 1, or 1 plus tan square theta. So instead of having what? Tan square theta here, instead of having tan square theta here, you just replace it with what? Sec square what? Sec square theta. So equals what? We have equal what? So just now what does this one mean also? Also you ought to recall that what? Whenever we have cos square theta like this, it is the same thing as what? Whenever we have cos sec square theta, we can also write it as what? Sin square what? Theta, don't forget. And sec square theta is the same thing as what? 1 over cos theta. So if you substitute like that, if you substitute like that, sec square theta over 1 over cos square theta, if you substitute these things to this, we are going to have another expression. So we have 1 over sin square theta all over 1 all over cos square theta. I believe you are following me. I believe you are following me. If you can box this one. So you have to be fast in exams when you are doing these things. So equal to now. This one is what? Square root of what? 1 over sin square theta divided by 1 over cos square theta. So when divided by this one, we arrive at square root equal to 1 over sin square theta times what? Cos square theta all over 1. So we are having root what? Root 1 times cos square theta all over sin square theta, which is equal to what? Now, also, cos square theta over sin square theta, if you look at what we did the other time, the one of the derivation that we did, that I can do that we did in the previous video, it means say that whenever I have cos theta all over sin theta, we have tan theta. Now this one is cos square theta over sin square theta, it means tan. It will be cos square theta all over sin square theta. Cos square theta over sin square theta will give you cot square theta. Cot square theta. So we have both cot square theta. So now we have what? Everything here is equivalent to what? Cot square theta. Because cos theta over sin theta is equal to take cot. Then carrying square with it, it will give you cos square theta. And the square root of cos square theta now, the square root of cos, because this square will cancel the square root. So what we have here is equal to what? The final answer we have here is equal to what? Cos theta, because this thing will cancel that. So we have successfully gotten this place. After what? Start from this place and we what? End here. We end here. So that's our final answer. The answer has been proved. It has been proved. Has been proved. Because we have cot theta as the answer. Cot theta as the answer. Cot theta as the answer. Proved. Cot theta. So cot theta as the answer. So now let's go into the second one as much as possible. Now let's try and do this one and try and this one and take it. Now we have what the first question says sin theta minus what? Cos theta or what? Or square plus what? Sin theta plus cos theta or square minus 2 equal to what? 0. This is the question they give here. Now, this is the question they give you here. Now, we are given here, we are given here, we are given here. What we just need to expand this bracket. We can expand this bracket. We have sin theta minus cos theta into bracket what? Sin theta minus what? Cos theta. Expand this one. Are you getting a question? Also, you can also do well to expand this one. Also, since it is plus, we need to put it there. So sin theta plus cos theta. Have to be careful here. All over what? Sin theta plus cos theta minus what? 2. Now I'm going to touch the left hand side. The right hand side. I'm going to touch it. I told you that the right hand side should not be tampered with. So you have to work with what? To work with what? The left hand side. And your left hand side, the value you get in your left hand side will be equal to what? That's what we show it. Whether you prove, we are proving what the question correctly or not. Now, from here, sin theta times sin theta will give you what? Sin square theta. Mind you, look at this. Sin theta times sin theta will give you sin square. Sin theta times sin theta will be sin square theta. Don't square this theta. Don't need to square it. You don't square theta. Only what square is the function. Sin times sin will be sin square theta. Okay. Now we are taking this one to multiply this. Now we are going to take this one to multiply this one. Sin theta times minus cos theta. Sin theta times minus cos theta. Look at this. Sin theta times minus cos theta. It will minus now. Then sin theta times cos theta. We put this minus here. Sin theta times cos theta. So we have the sin theta cos theta. That's what we just get. The first thing is the sin theta times sin theta. We get sin square theta. Sin theta times minus cos theta. We get minus sin theta cos theta. So now let's use the second one. Now, so let's use the first one. Let's use the second one. Minus cos theta times sin theta. It will also give minus because of the minus here. So cos theta times sin theta. So it will give you normally what this one come first. It's supposed to be what cos theta sin theta, cos theta sin theta. But you can still rearrange it so it will look like something like this here. So the arrangement does not matter when we are doing what multiplication. So minus cos theta times sin theta. We are using this one now. Cos minus cos theta times sin theta will be sin theta also cos what theta. Then if you use this one to multiply this cos, when you use this one also to multiply this cos, so minus times minus we have what plus. Minus times minus we have plus. We have plus minus times minus we have plus. Cos theta times cos theta we have cos square theta. Cos square theta. Cos square theta. So we have gotten this aspect of the word of the minus. Now plus you have to be very careful so this space can contain sin theta. The same thing happens with the sin theta times this one we have what sin square theta. Sin square theta. Sin theta times this we have what plus sin theta cos what theta plus cos theta times what the same thing you have what plus sin theta cos theta. The only difference is that now plus cos theta times plus cos theta times cos theta to give you plus cos square plus cos square theta plus cos square theta plus cos square theta. Now don't forget that you have minus 2 here, plus you have what minus 2 here, minus 2 here, minus 2. This is minus 2. So now from here now we can do something and do some. So we have what sin square theta now minus sin theta cos theta minus sin theta cos theta minus sin theta cos theta. This is one like minus 1 minus 1. So minus 1 minus 1 will be minus 2. Now sin theta cos what theta. You have done this one together. You have added to what to become 2 sin theta cos theta. Now plus what cos square theta. Are you following me? Now let's plus this cos square theta. Now plus sin square theta. Plus sin square theta. You have sin square theta also here. So you can transfer it to write down also sin square theta again. So it's sin theta cos theta plus sin theta cos theta. It will be what plus 2 sin theta cos what theta. Sin theta cos theta plus sin theta cos theta plus 2 sin theta cos theta. Now plus cos square theta, the one that is here, minus what? 2. Minus 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 2. Now please let's see this thing and this thing carefully. So now look at this. We have minus 2 sin theta here. Minus 2 sin theta cos theta. And we have plus 2 sin theta cos theta. You can, to avoid long our storage, to not make things what more complicated and more available. Let's just count from here. Minus 2 sin theta plus 2 cos theta. This one cancel out. So it means that one has cancelled out. Now we have what sin square theta now sin square theta now plus sin square theta. Sin square theta plus sin square theta. That is 1 sin square theta plus 1 sin square theta. We have what? 2 sin square theta. Now look at this cos square theta here plus this cos square theta. We have what? Plus 2 cos square theta. Now we have what here? Minus 2 equal to what? We are not putting anything here. Minus 2. We have minus 2 here. Now, I hope I'm getting it. Sin square theta plus sin square theta, 2 sin square theta, cos square theta plus cos square theta, 2 cos square theta. Now, you can do something here. This one has 2 in common. Let's forget about 2. This one has 2 in common. This one has 2 in common. What does it have? It has 2 in common. Now, let's factorize the 2. 2 into bracket sin square theta. 2 into bracket sin square theta plus what? Cos square theta. Bracket was close. These are 2 in common. Bring the 2 out. It means sin square theta plus cos square theta minus what? 2. Now, lastly, what we're going to do here, the only thing that we're going to do is from what? Cos theta we have said that sin square theta plus cos square theta is equal to 1. It means that everything in this bracket is equal to 1. Am I communicating? Sin square theta plus cos square theta is equal to what? 1. So meaning that everything that we have here now, everything that we have here will be equal to what? Will be equal to 2 divided by 1 minus 2. 2 divided by 1 minus 2. 2 times 1. We have what? 2 minus what? 2. So 2 minus 2 is equal to what? 0. So you can see that it's equivalent to what we have here. Everything here is equal to 0. Everything here is equal to 0. Everything is. So that's how you go about that one. That's how you go about that one. So it's a very, very, very easy thing to do. So thank you for watching us. The meaning will be done